Okay, great. My name is Melinda Webster. I am a sea ice geophysicist at the University of Alaska Fairbanks, and today I want to talk to you about snow on sea ice. What do we know about snow? It is highly reflective. In fact, it is the most reflective natural surface on our planet, but it also has this other effect, an opposing effect for sea ice. It's incredibly insulating, so it actually can inhibit sea ice growth. So I want to pose this question to you. Do you think that snow has a net good effect or a net bad effect on sea ice growth? And that's really what the frame of my work is about. On this picture on the upper left-hand corner, you'll see a really complicated schematic of all these interactions between the atmosphere, the snow cover, and the sea ice surface. We don't actually know how important these processes are. It warrants further investigation to capture, okay, what's it doing? How does it impact sea ice mass balance? And so we go out into the field to take measurements of these processes and figure out, okay, are they important or are they not? And then we incorporate them into models. So this is really a roadmap of what the future research at UAF will be about for snow on sea ice. Now tomorrow, I'm going to take one piece of that schematic. I'm going to be looking at these discrete accumulation events of snow on sea ice, and I'm posing the question of when do these happen and what are the mechanisms controlling the magnitude and the timing of these snow accumulation events. And I was going to start out with the easiest thing to identify, and that's cyclones in the Arctic. So what we've done in this analysis is we've counted every single cyclone that's happened over the Arctic sea ice cover when there's snow to see how much snowfall it's contributing. And if you want to know the answer, you can either ask me at the end of this talk, or you can come to my talk tomorrow and find out a lot more details. And for the next step of my research and what's ongoing is a collaboration with the National Center for Atmospheric Research. And this is coming back to that question of, is snow good or bad for sea ice? Especially as the Arctic sea ice cover has thinned dramatically over the decades and is less extensive. We think that the role of snow is going to change. But the first step of looking at this in a model is to see how well the model's doing. And to do that, you have to come back to these ground measurements, to these airborne measurements from NASA's Operation Icebridge, and bring them together, synthesize them to really get a valuable assessment of the model. So if you have more questions about this, come see me at the end of this. Thanks for your attention, and I'm happy to take questions. Yes? Yeah, I've focused a lot in the Beaufort and Chukchi Sea region. I did that for my graduate research and found that there's been a loss of snow in that region over since the 1950s to the early 2010s. And so it's thinned about, the trend is 2.9 centimeters per decade. But that's with an average snow cover of 30 centimeters, so that's about saying it's thinned by a third, which is substantial when you think about the ice albedo feedback, the snow albedo feedback, and its insulating properties. Yeah, thanks for the question. Any others? Great, thank you very much.